and this is Maryam, and I and Sumit will be covering the next half of the session for you all. So before coming on to the next topic, that is Netfilter, I would like you all to focus on some objectives or scenarios, and let us see for this one of the first scenarios that we have. In this setup, the setup which we already have is that we want to block all the traffic that is coming from client to server 1. Alright? So this is our objective, which we are going to configure in the coming slides. But let us understand the scenario first. Okay? So this is our first objective, where all the traffic from client to the server 1 has to be dropped. Okay? Getting on to the next objective, this objective says that all the traffic, and especially the UDP traffic that is coming from client to the gateway, should get blocked. Alright? I want you to just keep in mind the picture so that as soon as we implement the functionality, you have this picture in mind. The third objective for the coming topic will be to block all the traffic that is going from gateway to server 1 now. Okay, so these are 3 different scenarios at 3 different locations, and we will see how to implement it using Netfilter. So yes, this is when Netfilter framework provided by the Linux kernel comes into picture, and it makes use of the hooks or the chains, and these hooks and chains are present at different locations of the Linux network stack, and these will be implemented by one of the tools known as iptable tools to configure the rules. Now what I am talking about this hooks and chains will be much more clear to you all once we have the clear picture of the Netfilter hooks. So this is the block diagram for the Netfilter, and let me explain. As soon as a packet arrives, so if you can see all these chains or the hooks, namely pre-routing, input, output, post-routing, and the forward chain. So these are the possible locations of the hooks where we can add rules in for implementing different functionalities. And these functionalities, right? So these are the you can say possible locations where we want to write the rules in. Okay, so regarding the first chain, that is pre-routing chain, this is a location where all the incoming packets arrive, and that rule which has to be applied before a routing decision takes place are added into this particular hook, the pre-routing hook, right? After the routing decision takes place, we have this input chain, alright, and this forward chain. So if a packet is meant for a local host, then all the packets will be diverted to this input chain. Okay, so only the packets that are meant for a local host will go through this chain, and once it reaches the local process, it gets processed. In the other case, if a process generates any new packets, it will first traverse to the output chain. So all the outgoing packets will first pass through this output chain or hook. Okay, and then finally, before leaving, they will pass through this post routing chain. So this is one path which a packet follows once it's enter the Linux kernel stack. And then in the other case, if the packet has to be simply forwarded and it is not meant for the local host, this will have to pass to the forward chain or hook. Okay, and then finally the post routing chain. So the diagram may sound confusing to you, but I think except all hooks, if anyone can give me an idea now, like what's the basic difference between output and the post routing chain? Sounds similar, but there must be a difference. So anyone can relate? Just some general idea.
Any questions?
So here I think the packets
Yeah. Exactly. So the output chain has only the packets that has been processed by the local host, or you can say the newly generated packets by the local host. And the post routing chain will contain both the forward chain packets plus the output chain packets, whereas the output chain will only contain the packets that has been pushed by the local host. So I think this is the very little difference which you to keep in mind. So once when we are implementing the rules, we should know the proper location where to add rules. Yes? Yeah.
Yes, post routing chain can do both the jobs, right?
Yeah.
So why need the output chain separately? You can do everything in post routing chain itself.
Because there will come a time when you want to filter the traffic on the local host only. So that time the output chain will come into picture.
Got it. Okay. So there are two possibilities. You want to apply rules only for packets coming from the network.
Yeah.
You want to apply rules only for the packets that are generated by the host.
Yeah.
Or you have rules where you want to apply the rules
All the
packets
packets.
that are going out. So depending on that, it's either forward, output, or
Post routing chain. Is it now clear? Okay. So we'll see the possibilities and you will get yourself configure like which chain to use, which hook to use. Coming on to the next slide. So this were the functionalities which we were talking about. The Netfilter uses the iptables tool to configure all these network functions. So first we'll be configuring firewall, next as a network address translator, and then finally a load balancer. Okay. And now if to ask you the three scenarios which we have discussed, like in which category they'll fall into? Is it the first one, second or the third one? The three scenarios where we were either dropping packets from client or to server or just a UDP. So is it a firewall thing or a NAT thing or a load balancer thing? Yeah, I think firewall thing. So yes, we'll be covering the firewall thing first. Coming on to the next slide, the tool which I am talking about, iptables tool, it consists of a set of tables within itself to configure the routes. So now what are these tables? We'll be seeing here. There are three tables. First is the filter table, next is the NAT table, and the third one is the mangle table. And to identify the functionality of these tables, obviously first one is used to control the flow of the packets. So all the rules that are to be implemented in order to control the flow of the packets will be added to this filter table. Alright? And then NAT table, in this we'll be adding the rules if we want to redirect the traffic to some other interfaces. And then finally the mangle table will contain all the rules in which we want to alter the packet header intentionally, or some of the fields like TTL, okay, quality of service and all. So just keep in mind the names of these tables, because once we write the table, we will need to mention to which table it has to be added in. So these were the three tables which we'll be going to use. Okay. And yes, one more thing to keep in mind is here, not all the chains or hooks, the 5 hooks we have talked about, are available in all the 3 tables. Alright, so this is a relation between tables and chains. If we look at the mangle table here, it has access to the post routing hook, the forward hook, the input hook, the output hook, as well as the post routing hook. So you can say it has access to all the hooks or chains. Coming on to the NAT table, can you identify which hooks it has access to? I think it's clear to all. So if you can identify which hooks fall into NAT. Is it rerouting? Yeah. And output and the post routing hook. And finally the filter table has access to forward, input and the output hook. So now why is this limitation? I think once again when we'll be writing the rules and you'll know the functionality, you will be understanding yourself. Otherwise I'll be helping you out. Coming on to the building blocks of IP tables. So we have this Netfilter, which is using IP table tools, and IP table tools has multiple tables, the 3 tables which we have talked about, and each table contains a string of rules. Alright, all the rules are connected, and again each rule will tell us what to do with the packet actually. And the target again is the action which has to take place. Obviously a rule will contain the final action to take place. So the target defines whether to accept the packet, to drop the packet, or to reject the packet. So all these building blocks will be helping us to write the commands for the firewall in the first case. Back to the topic where we were discussing about IP tables and what tables it has. It has chains and rules and targets. Now we are about to write the rule for implementing a special functionality, that is firewall. And for that I want you to know the general syntax behind the command. So getting to the syntax of the command, let us first know what all the arguments the IP table commands take. So in order to write a command, we have to mention with a -t that in which table we are writing the rule in, be it filter table, NAT, or the manual table. We have to specify we are appending a rule with a -a, followed by is it a source, if you are checking on a source, so -s, or on a specific protocol -p. And finally, what is the target to take place? We have to accept the packet, drop or reject. So these will be approx used in all the cases, but particularly if you have to look at the rules which are present in the table, we'll be using the -L command. Okay, so whatever the rules in each table are present, it will be listed. And then finally, in order to flush a particular command, we'll be using the -F argument with the IP tables command. Getting to the general syntax, we have the command as follows. We need to use the pseudo privileges in order to use the IP tables, followed by, as I mentioned, the table name, -A, the hook name to add the rule in, the filter condition finally. In the firewall, we'll add the filter condition on what basis we are filtering the traffic, and then finally -J will specify what action to take place, like either to accept it, drop it, or reject it. And I'll not go much into the detail of the firewall, and I think most of you must be aware about the general idea about a firewall. Is it used for packet filtering, all the packets entering and leaving the network, and again we'll be using the IP tables for this to implement. Let's get back to the scenario first, where we wanted all the traffic from client to server 1 to get dropped. Now you know the tables, 3 tables present, you know the hook names, the 5 hooks present. You also know the general syntax of writing a command. I would now like you to please help me in writing the command. So if we get back to the syntax in the previous slide, we will be using pseudo IP tables, right? And since we are filtering the traffic, so which table to use here? Out of the 3 tables, filter, manual, and the NAT, obviously the filter table will be here, followed by the append, that we are appending a rule in this particular chain. So if you can help me to identify the hook to add the rule in. Do you want me to go to that particular block diagram of the chains? We have it previous. Previous one. The block diagram. Netfilter block diagram. So we have it here, right? Let's identify the hook where to add the rule in. In the pre-routing? Okay. Any other guesses? In the post-routing. We are blocking the traffic from client to server 1, and we are configuring the gateway as a firewall. You know? Let's remember it. Gateway is being
Once again, can you repeat that statement where show the location?
Okay.
Use a pointer or something. So
Okay.
that it's visible.
So this is the scenario where the traffic from the source 20.1.1.1 from 20.1.1.1 to 40.1.1.1 should get dropped. I just want you to identify the hook. I'll help you in the command. Please let me know which hook to add the rule in. So one guess is pre-routing, another one is post-routing. Any other guesses?
Forward.
Forward chain. That's the correct one. And may I know the reason, please?
So it's like we just added sometimes like a forward, like this gateway is forwarding packets from this subnet to the next subnet.
Yeah.
But I think it should work in like others also, right? Because like why just forward? I think it should work in all three.
Okay. The reason why you mentioned pre-routing, can you explain?
The CPU cycles. So because like if we attach that hook in post routing or
Okay.
like many CPU cycles will be wasted.
Okay, I'll get back to the reason. The post-routing one, who answered? You? No. Okay. If you're talking about saving the CPU cycles, so the pre-routing hook contains the entire traffic that is arriving in. Are you concerned with the entire traffic? Because it has the input, the traffic that is meant for local process also, and the traffic that has to be forwarded. So we're not concerned with the entire traffic, right? So in this case, I think input and output will be cancelled itself. These are meant for the local host only. There is no point in considering post routing also here, and the best choice is to add the rule in the forward hook. Alright? So let's write the rule, and Sumit will help us to write the rule in the terminal.
And my question was like, if we keep efficiency concerns aside, right?
Okay.
Like, but will it work in all pre-processing and post-processing and forward routing?
So because we are writing the rule in the filter table, we are now filtering the traffic, and the filter table has access to only the input, output and the forward hook.
So I think that
And-
picture that you
yeah.
have, right, where this-
Let's see the picture also once again. That spiral. Yeah.
where this one.
Okay, so this is the reason we'll have to choose the table first and the hook that are available, and out of that table, out of those chains, which chain to add the rule in. Okay, so yes, we'll continue with the command. Sumit will help us in writing the command. So since we are making the gateway as a firewall, we are running this command on the gateway. Sudo, let's correct the sudo. Yeah.
It's ping show it's working and then block it.
Yeah. First, let's ping. From client to server 1, let's see if it is working. It's pinging right or not. Just to cross check. So yeah, it's pinging successfully. Now we want to block this traffic. So blocking it, we are configuring gateway as a firewall. Going to the gateway. We are appending a rule -a.
So the rule start with like sudo iptables -a, which means that it should -a and forward like it is the chain name as we have seen, with D as destination 40.1.1 and J means like the action we have to take.
The command is understood by you all, right? We are specifying a particular destination and we are simply dropping all the traffic going to that particular destination. So we have, after pressing the enter, it will ask for the password. And
If we list it
yeah,
using
the hyphen.
-l command, so you can see that in this it is the rule is being added, and if again we will ping it from the client to the server, it will not receive the packets from that end, and like if we ping to another server which is .3, we will receive the.
It's working fine, right? We had two servers, right? So to server 1 it's blocking, to server 3 it's not blocking. So this was our first objective and it is accomplished. Let's get to the next objective. So it's always better to flush the rules in order to avoid any confusion further. Let's flush the rules first.
As the command is -f to flush, we will see that it will.
It's not present. So in order to frame the command for the next scenario where we are blocking all the traffic from all the UDP traffic from client to gateway. Okay, I'm just reminding you, we need another functionality, that is netcat. I guess anybody knows about it? If not, it is a wide command, but only the functionality we are going to use here are depicted here. So it is used to make a machine as a server. So we'll be using the MC on the machine which we want to act as a server and listen the messages, followed by a port number, -L port number. And the other machine which wants to send the message, we'll be writing the variant of it as MC, followed by the host IP address where we want to send the messages, and then followed by the same port number of the server. So this will be used in this next scenario. I just want to get you too familiar with it. Coming on to running it, so let's see this the demo also of the MC command. Sumit will be showing it.
So we'll start the listen at the server and L stands for the listen, and 1 2 3 4 which is we are specifying the port number here, and at client we will write the NC and the IP address of that machine, server 1 and the port number. And if we write some messages, it is being delivered
To the server.
so it works fine. So it works fine with this. And going forward with the scenario 2, so in that we have to specify we have to drop the add the commands to drop all the packets which is of UDP from client to server. So for this we have to specify the packet and on the chain which is we have 3 chains we have talked about. The first one is rerouting, post routing, and the
5 chains, right?
yeah.
5 chains. So yes, he's about to tell about the table. Again, the table is same, and the hooks which we're talking about, now you'll be guessing which hook to use. Again, we are filtering the traffic on gateway, and which hook to use on the gateway to add this rule in. Any guesses? Again, I have to use that particular diagram to remind you. Let's see. It's not clear. Input, forward, output, pre or post. I think it will be better if you guess first, then we'll be helping you out. Input chain, input hook, right? Or any other?
Please repeat the objective. Where is it coming?
Yeah, the question is all the traffic that is going from client to gateway and all the traffic that is UDP traffic should be blocked. The source is client, the destination is gateway, and it should see if it's UDP traffic, then it should get dropped. Input chain, any confusion here? Like the reason why, if you can tell me? Yes, the reason behind using input hook? Obviously you must have thought of something.
Because that's the only path.
Only path.
Forward, input, output. So if you have to block some packet, if it is going to some local process in that particular gateway, then only there is input.
Exactly, because here gateway is concerned, here the local host is concerned, and the only way to go through it is input chain. So we will write the rule in the input hook.
P stand for the UDP packet. And J stands for the action we have to take. Next,
iptables.
okay. So I will list it.
Let's check it. The rule has been added.
Your mic is speaking, the mic was not
Okay. And if we do the NC command that we have seen earlier, like if we do from the, we will start the L at the client side, which is gateway, and L stand for listen and U stand for UDP with the
use this. I will let you use that, or either of you can take one mic. You continue.
yeah, okay.
Keep your mic closer.
So we will start with the commands, which is like /P1234, which is the port number we have just specified, and if we do NC at the client side, which is specifying the port number, which is 20.1.1.1, and the port number, we'll see that there is no connection being established at this side because we have specified the rule. And if we go here and do the only L, which means that it will establish the TCP connection, and start. Okay, I have not started yet.
So what he's trying to do is open a listen command at gateway and send messages from client 1. Alright? So listen command has been opened and now he's trying to send messages from this to the gateway.
The IP address should be 20.1.1.2,
And
right?
20.1.1.2.
Okay, yes,
Yeah,
yes.
the address is this. Sorry.
So you can see that
Yeah.
it is being sent. Similarly, if we do with the UDP, which is this, we'll see that we have to specify the U stand for UDP here also. Okay. So it will not receive any packet. If we go and flush the rule, which is with the and again do the same with UDP. Let's see that it will listen.
So I guess the sequence is clear, right? We have made gateway to act as a server first through the MC command. We are sending some messages from client to this gateway and it is successfully being sent. After adding the rules and especially for the UDP packets, when we are sending the message, it is again able to send the messages because the rule is applied for the UDP packets only. So once we alter the command and send the UDP packets from client to gateway, it is not being able to deliver to the gateway. So is the objective justified? Command justified? Any doubt here? Okay, so let's quickly proceed to the third objective, where we wanted to block all the traffic from gateway to server 1 now. Again, I think you can quickly judge the hook name now. from gateway to server 1. The objective is in front of you. The hook name here should be all the traffic that is generated by the gateway to server 1 should get dropped. Which hook to use here? Output hook. Very correct. Let's write the command.
So I have flushed the rule of the IP tables, like if we list it with the L, we can see there is no rule has been configured. So we'll do same with the using the output chain.
And if the destination is 40.1.1.1, which is server 1.
And we have to remove that P which is specified the port number,
Simply drop it.
and just we have to drop all the packets. So now if we ping from this side, no, we have to ping,
From gateway to server 1.
yes,
We'll be pinging from gateway to.
Sounds slow.
What P or what will be the destination?
Sorry?
The IP table rule you are
Yeah, the
What will be
you have to specify minus 2 hyphen D. Not specify. Is
okay.
it correct?
So now it's
Rule has been added and we try to ping from gateway to server now. Not permitted. Rule has been successfully added. Alright. So these were the scenarios regarding filtering and implementing firewall network function using Netfilter hooks. Alright. Getting back to the next functionality or the network function, which is network address translation. And again, I think you must be having the general idea behind network address translation, as it is used to convert the private IP addresses to the public and vice versa. And for our scenario, we'll have two objectives again. What we want is, we have our client as with IP address 20.1.1.1, and if it wants to communicate with the server 1, 40.1.1.1, the client's internal IP address should not get revealed, right? So here again, we'll be taking help of the gateway, and it will act as a network address translator. So what our objective is, if the packet is in this form, where source is this and destination is this, we want our source IP to become the IP address of the gateway, and that too of the outer interface, that is 40.1.1.2. I hope the objective is clear of netting. This is our first objective. Coming on to the next objective, what we want in the scenario where server 1 is trying to communicate with the client, we want our, so in this case obviously the source IP address will be 40.1.1.1 of the server, and it wants to communicate with the client, which is 20.1.1.1. But since it does not know about the internal IP addresses, it just knows about the gateway's address. So it will write the destination IP address as 40.1.1.2. And what we want our gateway to do is map this address to the internal IP address of the actual client. This is our objective. And this is the main idea behind netting also. So, in the first objective, since we were changing the source address, right? So it becomes a type of NAT that is source NAT. And in the second objective, since we were updating the destination here, it becomes another type of NAT that is destination NAT. And again, I have quoted the diagram here just to let you know that in this case, SNAT will be using the post routing chain. I think this might be a question to you all, but is it clear why we are using the post routing chain here and pre-routing the DNAT? I want you to not mug, but understand why. What's the reason? Anyone? In the source netting, where we are updating the source address, we are adding the rule in the post the routing chain. Why is it so? Just a quick brainstorming.
Because that's the point where you need to change. Because before the every packet was in one variable to get, and when you are sourcing out the packet, that's
Yeah.
when you want to change the source address. Okay.
Yeah.
From now onwards, this will be the source address.
Obviously, yeah. So the main difference between the pre and the post is that the pre is happening before even routing takes place, and post at the end. So since we want all the traffic that is at the end of leaving, it should update the source before leaving. So all the rules that are related to S-netting will be added to this post routing chain. Am I clear? And then obviously the reason behind D-netting is that even before routing takes place, we want the actual destination to be updated. Only then can the actual routing decision can take place. So here we will be using the pre-routing chain for D-netting. Getting to the objectives that we have, what the objective is, the gateway should act as a NAT device, and this translation should occur, which is a type of NAT, that is SNAT. And the other one is to update the destination address, and this gateway should act as a DNAT. So I think both the scenarios are clear. And one thing I would like you to add here is that the actions that were being taken were simply accept, drop, and reject. So here two actions are being added here. After the -J, we need to mention, is it SNAT or is it DNAT, right? And again, I would you again to tell me which table to use here. The three tables that we have. Which table will be used here? The filter table again? Netting table, obviously. So yeah, the command goes as follows, and we'll run it parallelly. So we are configuring gateway as an NAT device. We'll add the rule on gateway. So to iptables. So just to explain, I think the table used here is NAT. We are using the post routing hook. If the destination, if the traffic is meant for the server 1, 40.1.1.1, in that case perform an action of SNATing. -J, SNAT is new here. And then change the source address to 40.1.1.2, which is the outer address of the gateway. Shall I show you the picture, okay? Or is it clear? The translation which we have seen is same. So we have listed the rule also, it's successfully added. Again, NC command will help us. If client is able to communicate with the server 1.
I think it should be there.
And the listen command on server 1. So if we send messages from client, it should receive or not? It should receive messages from client or not? We have flushed previous rules, forget about the previous rules. It should or not? It should. Obviously it should, and it is. But what the intention was? Intention is
achieved or not.
Very correct.
Yeah, T-sharp. We'll use T-sharp to observe that the address has changed now.
Yeah. And on which port should we run? On the left port of the gateway or the right port?
Yes, on which port?
Shall we show you the diagram? Yeah. On ENS 34 or 36? 36, right? Yeah.
If we go here and type some commands,
Yeah.
you will see that
Yeah.
the IP address is being changed.
So if we see, the source is 40.1.1.2, but the actual source was client, right? That was 20.1.1.1. And what, who is doing this? I think gateway, the NAT device is doing this. And we have simply flushed the rule. So let's write the rule for the DNAT also, where the target is when the server 1 sends a message to the client, it should translate the address of the destination. So this is the command, and rerouting hook is being used. If the destination is the outer port of the gateway, then it should change the destination to the actual client IP address. Was it the same? We were doing the same in DNATing, right? So this is the particular rule to write. Let's run it. Writing the rule of the gateway in the pre-routing hook. If the destination is 40.1.1.1, sorry, 2. Simply do the DNATing action, DNAT, okay, and change the destination to change the destination to the client IP address, that is 20.1.1.1. So I think the rule has been added. Still you can check it by the capital L option. Okay. It's always better to check first, so list the table.
Okay, sorry.
The tables, so write the tables. Hyphen capital L, and I think the rule has been added. So let's use again the NC command. Now we are running the server 1 to send messages to the gateway. Yeah. Not done client on the server 1. Yeah. Client means server 1. Listen.
Opposite DNAT, opposite.
Okay.
So you will see the message is being received for, like, if we want to see it is being changed or not, we will do similar T-shark on the client. the gateway, which is first we'll see on 34, and we send some messages. You will see, you are seeing that the source address is 40.1.2 and the destination is 20.1.1.2. Similarly, if we changed it to 36 and do this capturing the destination is being changed.
Is it justified? On the right hand side port, the translation is not working, but when we check to the left port of the gateway, the translation is working successfully. So this was all about network address translation, and if any doubt is there, please you may ask.
On this you can see with the lines also that first if we check on this port which is 36, it is 40, we are sending from 40.1.2 and we are sending to, this is the correct one, and if we check at the ENS 36 it is being changed.
Okay, so shall we proceed? So the final functionality in the network function that we are going to implement is load balancing. And I think again all of you are aware of the general idea behind load balancing. Its main idea is to distribute the incoming traffic across multiple servers. But again, something new will be added here. iptables will be using a new module known as statistic module. Okay, so addition will take in the query and statistic module will be used. And since we are targeting on the destination, we want the incoming traffic of the gateway to get diverted to either server 1 or server 2. We are changing the destination, so obviously which netting will work here? We are updating the destination here. So which netting? We have SNAT, we have DNAT. DNAT obviously, right? So yeah, let's see. The statistic module works in two modes. The load balancing will work in two modes, can work in two modes. The first one is random and the second is nth. So the random is based on simply probability. What probability you want the traffic to go on a particular server, and on what probability you want the traffic to go to another server. So whatever number of servers you can have probability for each server. So this mode works on that principle. And the nth mode works on the simple principle of the round robin. Like for a time counter, this particular server will receive the traffic, and for another server will receive the traffic. For our case, there are only two servers, so we will divide the traffic in these two servers only. Let's check the command quickly. I'll be explaining. So we have to use again the iptable tool, and in this case we are using the probability mode, right? Obviously we are performing a natting function. Nat table is being used. So the sequence may differ. You can add the table name first or the hook name first. So here natting is being used. Again, DNAT uses pre-routing hook. So we have mentioned pre-routing hook as in this probability mode. And if the destination is 20.1.1.2, which is of the server or gateway. If the destination is of the gateway, right? Gateway is acting as a load balancer, right? So if the destination is of gateway, then use the statistic module by -m. Use the mode as random and with the probability of 0.5. Divert the traffic to the destination 40.1.1, which is server 1 in our case. So query is little complex, but I think easy to understand. After mentioning all the table of the hooks and the destination, we are just simply specifying the module, the mode to work in, and the probability we want for a particular server to receive the traffic, and finally divert the traffic to that particular destination. In our case, since we do not have another server, you can mention as many servers you have. You have to add as much rules. If you have 3 servers, 3 rules will work, and here 2 servers are here. So obviously this is the default case. So after adding all these conditions, if obviously the destination is the gateway, simply divert the remaining traffic to the server 2, which is 40.1.1.3. If you want, you can specify the probability. Obviously it will be 0.5, the remaining traffic. If you do not specify, the remaining traffic will divert to the server 2. Now the second mode.
One thing I want to add here. In an IP table rule, when the packet matches the first rule, you stop there itself. Further rules are not processed.
Order will matter.
Huh?
Yeah.
The order matters a lot. So if the first rule is matched, rest of the rules are not. That's the reason in this case, you should first enter the first rule, and if the first rule is matched, then the packet doesn't go to the next.
Very good point to note. And round robin mode, the second one is round robin mode. So again, the module is statistic, the mode is now nth, right? The nth mode, the round robin mode. So what we are trying to do is, for every n packet starting from the packet number p, the rule will be evaluated for every n packets after p packet. So what we can do here is that we are trying for every second packet, but the packets should start from the packet number 0. So in this case, packet number 1, packet number 3, obviously starting from 0, 0, first packet, third packet will go to server 40.1.1.1. So you have just specified sort of time quantum here by using this round robin nth mode, and we want for every this sequence the packet should be directed to server 1, alright, and the remaining packet obviously to the server 2, that is 40.1.1.3. If you want, you can mention, otherwise the default case is this. So shall we write the command? And Sumit will be writing the command. I think we can write in the round robin mode. Yeah. We are configuring gateway as a load balancer, adding the rules.
Flush all the rules.
Yeah, it's always better to flush the rules.
So we will configuring the round robin one for this starting.
In the previous cases, we have not mentioned the table name in the command. So by default, the table is filter. Statistic module with the mode nth -. Destination. So this tool is for server 1. And
Similarly, we will do for the
destination के बाद change होगा.
If we go for the second rule, the other packets will be forwarded without changing the DRAM. Right?
If we do not add the,
Second rule, which you are putting right now.
yeah,
The other packets will be just
forward.
going forward without changing the
yeah,
address, right?
yeah.
So,
They will not be forwarding that, right? You just create the
like you're asking about the traffic which is incoming, it gets, obviously it will get forwarded. But in that case, which server to go, it will be, I think, the session which is open. If the server 1 TCP connection is open, it will go to server 1. Otherwise, the server 2. We will see it here, like.
No destination address is the gateway only, right? So it will stay at gateway.
Destination is the gateway, so packet will not be forwarded.
Okay,
Might
yes.
get
Yeah,
blocked
yeah.
there itself.
Alright.
We will list it.
IP table ready. Come on. Capital letters. बताते जाओ इसमें confusion.
इधर क्यों आ गया? So you can see that there is 2 rules being added. So we will do the NC both the servers to see the result. Here K stands for the multiple connections or threads being open for the UDP protocol. And we will start the command at so this IP is for the gateway. So
First
let's-
message sent, received by server 1.
again if we restart it, it will receive at server 2.
It's being received by server 2. So you might have the confusion by not in sequence, like alternatively why the traffic is not dividing. So it's not the case with the load balancing. It is just a percentage which is going to server 1 and not in sequence. Like if you want first message to be on server 1 and the second on the server 2, it's not the case. The traffic is being divided as a whole. Right? And why are we disconnecting again?
Yeah, because there is a thread which is being open. So first thread is connected to the server 1, so it will go to that at every time when we already connected it.
Yeah.
So we have to reconnect it.
The TCP connection has to be disconnected. By default, once a TCP connection has been established, the traffic will go to that server only.
It is UDP. Sorry.
Yeah, it's
It should not matter, right? It should not need to, because it's UDP connection. You don't need to close the connection.
in our case.
Okay, so this is one very important point with respect to load balancers that needs to be clear. So there is something called as flow stickiness property that every load balancer should have. So what is this flow stickiness property? What is a flow? So a flow is identified by a 4 tuple or a 5 tuple. So when I say 4 tuple, it is source IP, source port, destination IP, destination port. If it is 5 tuple, it is all these 4 plus protocol. So a flow is identified by that. And what is this flow stickiness property? If a packet of a flow has been sent to one server, if one of the packets is sent to one server, all the later packets should go to the same server. And there is a reason behind this property. That is, if there is some application processing happening, like let's say that there is some banking application that is running. Some state of this particular session is going to one server. There is some local state created. Now next packet comes, and if you send that packet to another server, the state is missing. Either you need to migrate the state or incorrect operations happen. So for such things to not happen, every load balancer should have this flow stickiness property. So whether it is UDP flow or TCP flow, a good load balancer maintains a stickiness property. And that's the reason of all the packets of the flow will always end up to the same machine. Is there any other question? Is it clear first of all?
Can it be disabled?
I don't know with IP tables, can you disable it or not? But should be, but I have not explored it. Yeah.
Like if some host is
Flush
down
करने
and
फिर
then
तो खत्म हो जाएगा।
a request comes in, then
Okay, the sticking
it
is
keeps sending to the same host, then it's
So that's the thing is that in that case, that's also a very good point. So that's a failure handling component, right, in a distributed system. So there is this concept of consistent hashing that is there, right? So if there is a failure, the node will be removed and either that particular connection that was existing, either that connection fails, so the client will have to re-establish a new connection, or there is a concept of connection migration. So when a new instance is added, you migrate the state to the new connection. But that state migration is not always possible.
usually load balancers we use to disable the state.
Yes,
For
yes.
this reason to keep it stateless.
Yeah, yeah.
So we have attached some of the screenshots of the output in case you run the commands later. And this was all about load balancing. So I think you are able to successfully configure a device as a firewall, as a NAT device, or even a load balancer now.